In this video, I am going to demonstrate how to install Ubuntu on an encrypted drive that can be auto unlocked using the TPM2 device. And the scenario here is that of dual boot with an existing Windows 10 or 11 installation. The complication here primarily is that uh, the standard Ubuntu desktop installer uh, it does not allow for side-by-side installation if the disk drive is encrypted by Bitlocker. The only way there is to turn off Bitlocker, and I don't think users appreciate that, having to turn off encryption just to install Ubuntu. So, and the other problem here with the standard installer is that it doesn't allow one to customize the installation in any way. For example, I prefer having separate root and boot partitions, but the installer will give me no chance to make such a change. The other issue that we'll be tackling here is that out of the box, none of the Ubuntu releases so far provide a way to enable the encrypted disk to be unlocked using the TPM2 device. Okay, so the first thing here, what we have to do is to make space for Ubuntu, and the best way to do that is from inside Windows itself. That's also the safest way, especially with BitLocker encryption enabled. Here I have got Windows 11 already installed in a virtual machine. You can see here hard disk 200 GB. I'll split it into 100 GB, 100 GB for Ubuntu and Windows. Also have the virtual TPM trusted platform module already attached. So let's start this. Here just search for disk management, disk MANA. You'll see this create and format hard disk partitions. Start it up. Here you can see 199.26 GB C drive, BitLocker encrypted. So just right click on this and say shrink volume. This will show you how much volume, how much space you have that can be shrunk. So this is how much I can shrink. This I will leave out around 100 GB for Ubuntu and around 100 GB for Windows. So let's do this. So here we have this unallocated partition. Just shut down. Now we have to install Ubuntu, but as I mentioned that the standard Ubuntu desktop installer does not allow one to has those limitations. It will not work with side-by-side installation, will not work with BitLocker. Encryption doesn't allow customization. So we'll use Ubuntu server installer, which is a text mode installer, but it's quite easy to use, and it will allow us to do custom storage layout where you can set up LVM encryption and all that. Once we have installed the server, we'll simply switch over to desktop, and this is just a matter of running a couple of commands in Ubuntu using its meta packages. So first let's download the Ubuntu server ISO. Here it is, get Ubuntu server. So here you can go and download the ISO file. I have already downloaded it, so I'll just use it. In a physical machine, you'll need to write that ISO file to a USB pen drive. There are many tools in Windows and Linux that allow you to do that. For example, in Windows, you have Rufus, which is the most popular. When Linux distributions typically already have an inbuilt disk writer. For example, Ubuntu comes with startup disk writer, so you can use that. Once you've done that, just attach it to your machine. Here I will just attach the ISO as a CD drive to this machine. So here we have this live server ISO. I'll attach it here. Just save it. Now I'll have to, when I start, I'll have to go into the BIOS to change the boot order. In the physical machine also, you'll have to do something similar. So select from the boot menu as to which one, which disk you have to this. And here I have got the SATA CD-ROM type. You can see in the boot menu. Likewise, in the physical machine, you will have USB disk or something like that that you'll have to choose as the boot device. Just go with the first option, try or install. So now this will take a while, a couple of minutes, so we'll come back. Here it has booted up, and you can select the language. Let's select it, and you can change the layout, keyboard layout if you want. Just go with the defaults here. It will select your device to connect interface for only the Ethernet interfaces, and some of those will be selected here. If you have a Wi-Fi interface, you won't be able to set it here, but that doesn't matter because you can just do an offline install, and later on after installation you can do the updates and whatever required. Let's check the mirror location. So here is the custom storage layout which we'll select, and here we'll see that this allows for creation of volume groups from here and also encryption from inside. It will allow that. But here you'll see that the free space that we created, that is not visible here. So we'll go to another terminal and first create the required partitions in the free space and then come back to this. So to switch the virtual terminal in Linux, you have to use Alt F1, F2, F3, so on. This is on Alt F1, the first virtual terminal. I'll just use Alt F2 and switch to second terminal. Now you can use fdisk-l. I'll pipe to less so I can see all the disks that I have. Now most of these are just loop devices that are used by the installer. Here towards the end you will see this NVMe disk. If you have a SATA disk, you will see SDA, SDB like that. So here the devices dev NVMe 0 N1. So I'll use CG disk to open this NVMe N1. Now here you can see this free space. I'll create two partitions here, one for the boot device where the Linux kernel image and entirety will remain. This will be unencrypted because the grub bootloader does not have support for uh, unlocking the unencrypted Lux volume using TPM2. And enabling that in grub requires rebuild of grub and then installing your certificates, etc., in secure boot and all that, which is very long, complicated, and error prone. Also, it doesn't work on all the devices. So realistically, the only option here is to use a separate unencrypted boot device. In my opinion, it's not a security problem for almost all cases, except if you're working in a very high security sensitive environment. But then I don't think in that scenario you'll select a TPM to unlock in any case. Uh, so yeah, we'll go ahead. I'll go ahead and create a boot partition and then rest of it for Linux root, home, etc. I'll give 1 GB as the size of the boot partition. I'll just give some name like Linux boot, and then the rest of it, just choose the defaults. Now we can go and write these changes and quit it. Now we'll switch over to the first virtual terminal using Alt F1. Here, go back and load it again so it sees the changes. Now here you can see the 1 GB and 98.90 GB, two partitions that have been created. The first step here is to select the installation drive, which is this one. So enter here and select use as boot device. Here you'll see the EFI partition, which contains the bootloader. Windows already has created it and added its bootloader there. Ubuntu also will use the same partition to install its bootloader. And the UEFI firmware of the machine will look at the bootloaders from in this partition and boot them. This one will edit and format as ext4 and mount on boot. The remaining will create a Linux volume group, a LVM volume group on this. Now, Linux volume manager, what it allows us to do is just create a, a volume group on multiple one or more physical partitions. So they appear as a single drive, and in that group you can add any number of logical volumes. The advantage is you don't now have to worry about the layout or the sizes of the volumes, because you can change, shrink, expand the individual volumes at any point. Furthermore, the Linux volume group itself you can expand and shrink as required. So like in future, let's say you add a new hard disk to your device, then you don't have to worry about how to use that hard disk effectively. All you need to do is just create one or more partitions on it, and then add those partitions to this volume group. So automatically all your logical volumes will be able to see the additional space. Then you can expand your individual logical volumes inside that volume group as required. So even on all desktop machines, I always prefer to have LVM installation, so that in future, if I have to do any disk expansion, etc., it's very easy to do using LVM. I'll go ahead and create a volume group here. I will select the last partition 6, which was the empty partition. You can see the size 98.90 and create encrypted volume. You give some passphrase here. This is just some useless password, but you obviously should have some really good password here, really strong, which is not prone to any dictionary attacks. And then keep a secure copy somewhere, or at least a hint to remember it, because at least especially now with TPM2, you will not need to enter that password many times, so you can forget it. So you have to keep a secure copy somewhere. You can also create a recovery key and then keep that securely somewhere. So whatever way you prefer, go ahead and create. Now here you can see this VG0 new encrypted volume group, and it has this much free space. I'll go ahead and add two partitions, one for root and one for home. I don't have to worry about sizes at this point much, as I mentioned, can shrink and expand sizes later at any point using LVM tools. So I'll create first root, let's say root-lv, and let's say 30G, and then create home, keep the remaining, Here I'm always using ext4 as the format. It works the best. It has worked the best, most stable way for me over like past 10-15 years I've been using. Secondly, the file system, whatever you use, should itself support shrink and expand features to be able to use the corresponding LVM feature. If the file system itself cannot lacks the ability to shrink or expand, then obviously LVM cannot magically add that capability to that. So ext4 is the best overall with LVM, in my opinion. So this is the layout we are using, and we will just now go ahead with this. Just enter your name, server name, username, and password. Ubuntu Pro, yeah, I don't want to enable it now. OpenSSH server, not required. This is all server side stuff we don't need. In any case, we'll be switching over to desktop installation later. This will take a few minutes to install. So let's come back to it once it's done. Okay, so installation is done. We'll go with the reboot. Now in the boot menu, you can see Ubuntu and Windows. Go ahead and boot Ubuntu. The decryption here in the virtual machine takes a while. It's much faster on my physical machine. I guess because this lacks some hardware support for RSA decryption and all that. Uh, this server side boot doesn't have splash screen, etc. I'll enter the password. Once we switch over to desktop, we'll have all those fancy stuff. Okay, so to switch over to server, so before doing that, what I always do is install apt fast, which is much faster for me, at least with India mirrors. It is much faster at downloads. It will uh, so it will download in parallel and finishes much faster for me. If your own mirror is quite good and saturates your bandwidth, then you can skip this skip this step. I always use this in all my installations. PPA apt fast, yeah, stable. Okay, this is not in the standard repository, it's in a PPA. I just enable that PPA. Use apt for the measure maximum number of connections. I keep as 10. I'll install Ubuntu desktop. If you prefer another sorry, if you prefer another flavor like Ubuntu or Xubuntu, you can use that. I'll also add restricted extras add-ons. Kubuntu, Xubuntu, Lubuntu also have the similar name. Kubuntu restricted add-ons and so on. And the same command will also remove uninstall Ubuntu server, but we'll have to retain two packages, which is LVM2 and crypt setup, which are for the LVM and encryption. Otherwise, because they are dependencies of the server packages, they will also get uninstalled, which obviously we don't want. So here we'll say Ubuntu server minus to uninstall in the same command. And there is another Ubuntu server minimal, which also will do minus. I'll also add auto remove so that all their dependencies also get uninstalled, not just the meta packages. Also add purge so all the configuration files also get removed. So here this is the download. Just go ahead. I can see it's doing in parallel. At least for me, it is much faster than plain apt or apt-get. So it'll do a bunch of changes. We can just go ahead and continue. This will take some time to finish, specifically because of the Snap Firefox, like this Firefox Snap and Thunderbird Snap, which will come later. In India, mirrors, especially for Snap, are not fast. They're a bit slow. So this will take a while. We'll come back to it. The installation is done. Now we can make a couple of changes and a couple of differences between the desktop and server setups. So first change which we'll have to make is disable systemd network D. The desktop installations all use network manager and it conflicts with systemd network D, which the server install uses. So we'll just disable this. The other change which we'll do is if you want the splash screen during boot up, what the desktop installs show, then we can add it to the grub configuration. So edit this etc default grub configuration file and add quiet and splash here in the command line default. Also, you can uncomment this grub disable OS prober so that it also discovers other OSs. Though I think Windows it will do discover with even without that. Go ahead and run update grub. Here we'll see Linux and uh, Windows which have been. Now after this, what we can do is install HWE kernel, which is used by all desktop installs. HW is hardware enablement, just a fancy name for a more recent kernel. It's useful for desktop installations because it supports newer hardware. So if you plan to add new hardware in future, or even you have currently, it's better to have the HWE kernel. So what we want to do is here is install Linux generic HWE 24.04 kernel. Now here you will see this downloads, they are essentially failing. That's because of that network D and network manager conflict. So in any case, at this point we'll go ahead and reboot. boot into Ubuntu. Here we have come to the second part of the video. I'll now show how to enable TPM2 unlock for the encrypted device. There was a thread on Ask Ubuntu where this question had come about on how to do that in Ubuntu, and I was also doing that at that point. I came across that thread and I found this way of doing it reliably. So I left a comment on that thread, one of the answers there. We'll go to that page and just copy the instructions from there. Okay, here we have the unlock. Now you can see the splash screen, etc. for the desktop installation. Yeah, just skip all this. So we have successfully transitioned to the desktop installation. I'll fix the display size. This happens in this virtual environment. On terminal, we need to dash, move it up. Okay, let's start the browser, and you can open up that page, and then copy the instructions from there. Just search for Ubuntu TPM2 unlock encrypted device. Let's say LVM, something like this. So yeah, here in Ask Ubuntu, you'll see this thread, the first thread itself. I'll skip the updates for now. We'll scroll down towards the end, you'll see the answer that I had written. So just copy the first step from here. This will install Draycut and uninstall init tools. These are the tools used to build kernel image and initrd image. The Draycut is more advanced, and it will likely replace init tools in Ubuntu in near next release or next release. So now here you can see that instead of init the Draycut is generating the boot image. The reason we installed Draycut is because init lacks the support for transparently decrypting using the TPM2 device. Next step is to create this script like this. You can name the script anything. You just copy this and create a script. Let's say usr local sbin tpm2 lvm enroll. Copy this, paste this. Here we'll have to change the UUID for the root device as per your installation. You can find that in etc script tab. I'll split open that. Okay. So here we go. Here you can see these PCRs I have selected on that in that page. In the comment you will see I have given links where you can see if these suit your situation, uh, and you can add remove from these as required. But I won't recommend adding too many, otherwise for every little change you'll have to re-enroll the uh, key in TPM2, which will defeat the whole purpose of uh, adding that support in the first place. Now I'll go and make that executable. We can run this script right now. Enter the passphrase, which is VM4, whatever passphrase you selected, and the TPM2 pin. This pin will normally be much shorter than or simpler than your passphrase, because offline dictionary attacks are not possible against TPM2 pin. The TPM2 device will lock up after a few failures. So you can have just a simple, much simpler to remember passphrase here. Even though it's called pin, you can have any characters here, so it's just like a passphrase. So enter the pin. Anyway, that's the whole point of using TPM2 in the first place. If you don't want to have pin at all, then you can remove that option from that script that we just created. But I think I'll recommend against doing that. It reduces the security significantly. Just having a simple enough pin also suffices. But attacker obviously should not be able to easily guess it in a few tries. So next, let's go to the next step. Here, just last step is to update crypt tab. We'll have to add the TPM2 device here. So I'll copy this, just this line from here. Sorry, copy and paste it into crypt tab. Here the second option you see TPM2 device is required. The other three are good to have for SSDs. They will improve performance of SSD significantly. If you have any concerns about that, you can look at the comments there, and I have given links on more details so you can read up. Discard specifically, it has some security implications. I don't think it affects normal users at all. But if you are concerned, you can avoid adding that option. This TPM2 device equal to auto, this is required. Restore for SSDs. So lastly, we'll have to create a configuration for Draycut, whatever. You can give any name here. Just call it tpm2.conf, and just paste this what options have given at the start. This adds the TPM2 module to the image, initRD image, and also it has this host only equal to yes, which is required so that it includes the crypt tab and fs tab, those files of your system specific files. And it also, because it's system specific, it will reduce the size of the image significantly. I also normally add compress equal to uh, zstd. This one creates smaller images than the default gzip, and also it decompresses much faster. So it's good to have. I use this normally. Now we can go ahead and install the HWE kernel, which we were attempting earlier. Here it is. Let me just use apt fast. Otherwise it takes a while to download, especially with India Mirror. Okay, this is also going quite slowly. Let me retry. Maybe I'll have better luck. Okay, so this India Mirror seems to have gone down in speed significantly for some reason. Okay, now it's back up. With Dracut, one additional advantage you'll get is with host only, the size of the init RD image will be significantly smaller, as I mentioned. Plus, you can configure it much better. So, for example, if you have later on install NVIDIA drivers, um, they will get included in the init RD and will increase the image by significantly. Like for in my case, it was going up to like 170 MB, and you can exclude that in the configuration using omit driver modules and then NVIDIA-UAVM, etc. I can, if someone is interested, I can give more details, discussions, uh, and that will reduce the size for, in my case, from 170 MB I went down to like 20-30 MB, and also boot time was significantly reduced, like almost halved. So the only downside was that that fancy splash screen became less fancy, which I don't mind at all. So these kinds of configurations you can do easily with Dracut. Now here we are actually done with all this. I'll go ahead and reboot. In the first restart, the TPM2 pin will not work. And that's because we changed the configuration significantly, like installing Dracut first time, etc. It will refuse to give out the keys. So we'll have to enroll it again, run that script, which will enroll it again. And from next boot onwards, it will start working properly. You can also reduce the PCRs there, specifically number 8. So you can see here, it won't work. So you'll have to enter the full passphrase the first time. In the PCRs, as what I was saying is that in the PCRs list, you can, for example, remove 8. Then I don't think this will happen. But I like to keep that 8. 8 is for kernel command line. So if you're booting in recovery mode or someone is trying to boot with custom group command line, then this TPM2 encryption will, TPM2 will refuse to give out the keys. So we'll enroll this again. Enter the passphrase and then the pin again. Now it should work. Now, whenever you have a significant, let's say, hardware change, or you change BIOS settings, etc., then you'll have to do this TPM2 pin re-enroll. And in that boot, it won't work, and then you'll have to enter the passphrase there, like we did this time. After this, the TPM2 pin should work. So here we go. So that's all for my side. If you have any questions, any further discussions, then we can add to comments to this video.